There we go. So these first ones, a closed loop that electrons can travel in, that's a circuit. Power is the rate of electrical energy use. Resistance is something that slows down the flow of electricity. Voltage is the pressure that pushes charge through a circuit. I'm going to talk about a different, sort of a different way to think about voltage. Mr. Chase likes to use voltage as energy. Another way to think about voltage is a hill. So if you have a hill, the battery kind of pumps stuff up to the top of the hill, and then it goes down the hill and loses all of its voltage, and then it gets pumped back up to the top of the hill again. So we should readdress it. This is, if you think of this as water, water can get pumped up to the top, and that creates water pressure, which drives it down the hill. The formula for calculating this is IV, so that's power. Power is current times voltage. DC is direct current. That means one direction. The amount of flow, that's current, and then the type of circuit in which a flow switches directions, that's AC, alternating current. So if you use the triangle on this next part, you'd set it up like this: V equals IR. So cover up the I, and you get V divided by R. Cover up the R, you get V divided by I, and then cover up the V, and you get IR. And this also works for power. Power equals current times voltage. So you can cover up the, if you want voltage, it's power over current. Power is IV, and then current is power divided by voltage. Number 12, here a lot of people missed these in the other class. There were only 2 or 3 people who got them all right. So voltage is kept the same. Here's voltage, it's the same. The current is increased. What has to have happened to resistance? And it has to get smaller. So if you keep that the same, you make this bigger, this has to get smaller. If I put in numbers for this, I could do the number thing. Let's just say voltage is 100, and each of these is 10. So if I make this 20, and I keep this at 100, this now has to be 5. So current's been kept the same. So this is the flow. We've got the same amount of flow through the circuit, but there's more resistance. So if you add more clogs to a circuit, but you keep the same flow, you're going to have to push harder to keep the same flow if there are more clogs. So the voltage has to be increased to make that happen. And numerically, if I start with this and I go to this, I could say that current's still 10, but now the resistance is 20. So this has got to be 200 instead of 100 like it was before. And then finally, if I keep the resistance the same, so this is the same size R, but I decrease the voltage, imagine trying to push something through a pipe with the same amount of clogs in it, but you're not pushing as hard anymore. What's going to happen is you'll have less flow. So that goes down. So the answers are decrease, increase, decrease. And numerically, again, if I make this a 10 and I shrink this to 50, then this has to become 5. It has to shrink too. Number 13 and 14 are series and parallel. So in a series circuit, which is what this is, all of these bulbs have the same current going through them that the battery does, because all of the current has to go through every bulb. So this current and that current have to be the same. So this says individual currents equal the total circuit current. And for this one, this says the individual currents add up to it. So that would be like this one down here, which is the parallel. We've got the overall flow of the river, but it's dividing into 1, 2, 3 separate channels. Each of those is going to have a third of the overall flow. So whatever the current is through this channel, that's got to be 3 times as much, assuming they're identical channels, which they are. So going through the steps of this, can you guess what I did first? Very first thing I found here? No, I didn't. I couldn't do that voltage. Well, there is a trick for doing voltage first, but this is what I found first. And I think what I do is I have Ohm's law in my head, V equals IR. And if I have any two of these things, I can find the third. So I've got V and R right here. So all I need to do to find current is divide V by R. So 12 divided by 6 is 2. And then I'm going to make the triangle like this. P, IV, P equals IV. So once I've got I and I've got V, I can just multiply them together to get this P. Then I have to know a little bit to get working out here. I've only got R, so this triangle isn't helpful if all I've got is R. But if I know that this is series and the current through here is the same as the overall current, then I can put 2A there. And now I've got current and I've got R, so I've got I and R, so I can find V. So if I want to find V, it's just IR, so I just multiply 2 times 2 and I get 4. And then finally, if I want P, I just multiply V times I. 4 times 2 is 8. The bottom one, the place I started with that was I couldn't use Ohm's law right away here because all I've got is R. And over here, I guess I could find P. That's the only thing I'm lacking. I could just multiply V times I and I can get P. But in order to get going here, I've got to use the fact that this is parallel, so this current plus this current plus this current add up to the total. And since these three bulbs all have the same resistance, they're all going to have the same amount of current. It's going to divide equally. So if this is 3, this will also be 3, and that'll be 3, and they'll add up to 9. So once I've got that 9, then I can use Ohm's law, and I can find voltage. Voltage equals I times R, 9 times 2 is 18, and power is V times I, so 18 times 9 is 162. That's it. Let me